Hello everyone. Welcome to the monthly EasyPower webinar series. My name is Jim Chastain. I'm your host for today's session. Our topic today is a very timely one on a new phase of electrical safety. Before I introduce our guest speaker, I'd like to cover a couple housekeeping chores. First of all, everyone in attendance today will receive a certificate of attendance, and that will be sent out via email. You don't have to do anything to prompt it. They usually come out towards the end of the week or early next week. Secondly, I'd like to call your attention to the control box for the GoToWebinar session. The handout entry includes a copy of the presentation. So those of you that are so inclined, you're welcome to download that as necessary. So with that, I'd like to turn the presentation over to the electrician, Mr. Chuck Fox. So Chuck, give me just a second. We'll make you the presenter.
Well, good morning, everybody, and welcome to our the EasyPower webinar series. EasyPower does a great job of this in the market and has essentially tracks of two series. One is, of course, their Tuesday series, which focuses on specific topics related to capabilities within the EasyPower software suite. And then the Thursday series here, which gives us an opportunity to address broader industry-related topics and standards on that. And again, Jim, thanks again to EasyPower for giving us the platform and allowing us to share our topic today on that. So today what we're going to talk about essentially is take a look at the NFPA 70E standard, frankly, through the years, and particularly encompassing the topic of safety-related maintenance, and now pull in the larger discussion in the major changes of NFPA 70B, which has now been promoted as a standard. So together we can look at both of these publications and develop this overview of, I'm going to call it an emerging view of safety-related maintenance, and ultimately within the regulatory or the articles within both of these publications, how safety-related maintenance over the years has become an evolving standard on that. So again, as we look at this, we're going to be looking at NFPA publications of both Article 70, the National Electric Code of typically what I'll call the building requirements, how to build out an electrical system and its various specifications. 70E, of course, is electrical safety in the workplace, and now 70B with its new and improved title of electrical safety requirements on that, or safety-related maintenance. So as we look at those, we're going to continue to kind of explore what's in there along the way. Before we get started deeply into that, I kind of wanted to just cover a bit of an overview of the role of these NFPA publications. So ultimately, NFPA as an organization will facilitate the development of these standards, and over the years now, a very structured approach. The three standards we just mentioned, of course, are all on what we refer to as an ongoing 3-year revision cycle, and we can look back through the various additions that have happened along the way. But the very process of developing the standard brings together those that are accomplished industry volunteers that represent different viewpoints of components of the electrical industry and electrical safety practices, and ultimately develop the language that becomes the changes from one edition to the next as we move through the editions of the standards along the way. So even though those standards change, one of the other questions of the day that we frequently need to address is who measures compliance? And ultimately the language of the 70 of the publications themselves basically says you do. You literally will take apart a review and understanding of articles, assess how you might look to implement those compliance requirements within your organization, and ultimately have you gone far enough and deep enough. That assessment is basically an effort within the organization. Now, with that said, you might want to engage discussion of professionals that have worked with those particular standards for quite some time. But it's a pretty open-ended question of, have we gone far enough in a certain level of compliance efforts to be compliant enough, would be a way to say it. And then ultimately, as outside companies, those that provide services to help companies meet these NFPA standards, again, if we're saying that we have a set of services that will meet the NFPA article references and be of sufficient compliance requirements, NFPA specifically will state that the one that is making that type of claim is the one responsible for it, and NFPA themselves do not make those kind of claims on their own. So with that kind of background of the nature of these publications, they are considered industry standards per se, and that companies are encouraged, of course, to be able to put together the programs and practices and the various compliance efforts it takes to be in compliant with the standards. And ultimately, the only one that's going to come back and assess, did you go far enough, maybe OSHA, if they get involved in some level of, investigative review at any one of your sites. And of course, the biggest opportunity for that to happen would be some level of significant accident that OSHA would look to take upon and review and do their due diligence of investigative processes per se. So as we look at this topic of safety-related maintenance, and then particularly within 70E in our past and present, we can literally start from 2009 and fast forward through all of these revisions as a bit of review related to our topic on that. So as we take a look at these, the 2009 edition was the very first time that the 70E standard actually required device-specific labels. And then within that, there was the methods of either using the incident energy calculations, that is one of the functions we get from our EasyPower software, or in the standard yet today is this category method of different protocols and such. But equipment shall be field marked with a label. That standard has now been around since the 2009 result on that. And we can cross-reference that particular example, of course, with the OSHA requirements that a facility shall assess the workplace for hazards. And the deliverable to ultimately say that we have assessed the workplace for hazards is the information provided on an arc flash label, as we can look to, again, cross-reference those particular compliance challenges. So essentially the nature of ultimately doing the arc flash hazard analysis and establishment of various worker safety boundaries was part of 2009. 2012 brought us the need to frankly document many of the things which were in the 2009 standard. The arc flash study or arc flash hazard analysis, having a written report was actually a requirement to 2012. So you could do a study but not have a report in 2009. That's kind of how it laid out. But now, as we see, they kind of close the loop on that as they move forward with the various requirements in the subsequent result on that. Beginning of tests, maintenance tests, and inspections of having that documented, and then host employers are contractor type meetings are examples of many of the things in the 2012 edition that was considered the standard of documentation as I describe it. 2015 standard marked a major shift into this role of safety-related maintenance. So condition of maintenance, the labeling of incident energy, and maintenance tests and inspections were indeed new references within that particular 2015 reference on that. The very mission statement, Article 90.2, or scope of the 70E standard, changed to include the word safety-related maintenance in this 2015 edition. So again, that's just that major shift to now encompass safety-related maintenance as we weave that into various article references and compliance challenges within the 70E standard on that. 2018 brought even additional support to that. One of the big changes in 2018 was the addition of NEC level inspections. Interesting enough, the way that language is written into the 70E standard, it speaks to, frankly, inspections of just new work and new equipment in the building. Fast forward into our 70B requirements, we're going to find that now we look to inventory inspect all equipment, again, as we merge these standards together over time. One of the other broader requirements of this whole concept of safety-related maintenance was actually the entire written electrical safety plan. So the top changes in 2015 are listed here, and like the job safety analysis process or listing within that literally relied much upon much of the data of the arc flash study, and be able to pull that information forward in order to both document what the safety standards are and then react to them accordingly for the project team that is engaging in that energized work along the way. And again, the reference to human performance within the Annex Q is also a pretty major addition to the discussion of the total of employee safety. 2021, with the addition, I'll say, in the challenges of COVID, the changes of IEEE 2018 to change the calculations. EasyPower and the various other software providers had to do some scrambling back then to bring these new equations and new calculations into the software to allow the options to allow the results of incident energy based upon those new standards. And again, things were moved around in the standard, but ultimately within the 2021 edition, there really wasn't any truly new initiatives or new embellishments related to our topic of today. 2024, one of the significant changes is that each one of the articles got a new first entry of the scope of the article itself, which of course, if you're trying to write proposals and practices that reference specific 7DE article references and standards, all your numbers got moved around when you went through that along the way. Again, they described that priority and clarity were some of the changes in the standard, but from a topic standpoint, not necessarily anything new. But one of the very new things was a brand new annex that was added, Annex S, that was assessing the condition of maintenance. And in there is a bit of a discussion of how does one go about assessing condition of maintenance and its protocols for doing so. And literally at the end of that particular result, we see that the result is to reference 70B as well. So if a company asked me today to get started, where do we begin if we haven't done anything yet? And ultimately the checklist that we give them is you need to do a risk assessment, because OSHA ultimately is wanting you to assess the hazards of your workplace and of your facility. So ultimately the arc flash study begins that foundational building block of providing the information to do a risk assessment. Today, that risk assessment should include a visual inspection versus, I'll call it, just engineering calculations. And as we'll flesh out things from the 7DB standard, your program itself shall now include periodic testing and inspection of your electrical equipment, and maintaining the maintenance history, keeping your device labeling up to date, and again, having the means to store and share this information. And again, that references the 7DB standard. So here's kind of that checklist that we get started with to help companies go from there along the way. Annex S actually closes out its discussion with a discussion here of 70B that provides the means to establish and maintain a acceptable condition of maintenance and condition of electrical equipment components on that. So again, the reliability does cross-reference, and here we are seeing yet a very visible example of 70E cross-referencing itself to the 70B references. Well, with that bit of a historical background, we kind of can come back through those same revision cycles, if you want to call it that, and look at very specific building blocks related to our safety-related maintenance discussion on that. So as far back as 2009, there was first the reference to perform the arc flash risk assessment under Article 130.3, and it says equipment shall be field marked containing that available incident energy or the required PBE level. And then skipping down to the bottom reference, it says that arc flash analysis shall take into account the design of overcurrent protection devices. And again, the only words listed in all of 2009 for condition of maintenance was this one reference here of the arc flash analysis shall take into account condition of maintenance. And then from a short circuit standpoint, Article 210.5 did a hint to basically said we need the results of a short circuit audit to determine that our protected devices or the adequate withstand rating of those devices compared to interrupt available fault current is where it needs to be as well. So while that gives us a hint that a short circuit study shall be done, really we don't see that anywhere else in the 70E standard through the years. But now we see it as specifically referenced as one of the studies in, of course, the NFPA 70B standard. So again, we talk about the 2015 standard and the scope article reference of safety-related maintenance, and then beginning the reference that an electrical safety program must consider a condition of maintenance level of elements and protocols. So what does that mean? We need to plan those out with the requirements on that, but again, pretty short-sighted as far as a more complete shell of what is that electrical safety program and condition of maintenance protocols. In 2018, the electrical safety program, I'm going to call a table of contents or elements that would be in your electrical safety program. The 70E standard added into that the inspections criteria, and again reference that condition of maintenance program as well. And again, we see the one more embellishment to that as we look at 70E all the way to 2024. Within that electrical safety program and the written documentation, the real push for that, as I see it, was the 2018 edition, where we talked about the electrical safety program, but clearly in 2018, with the reference to Article 105.3, the established, document, and implement a safety-related work practices really put it forth to be a written or documented plan as being really one of the emphases on that. Now, I won't go into any deep detail on this, but with EasyPower back in February of 2023, we went through our journey of developing the electrical safety program or plan, and we actually set aside the structure of the Annex E sample that is provided in 70E for really two reasons. It's informational purposes only, and that the structure of the way that plan was written was something that we felt we couldn't write an adequate plan to. And ultimately, here's the reference to that, and you can find that in the EasyPower references. And a long story short, when we wrote an electrical safety plan, we broke it out into these 5 chapters and organized the chapters in this order, as opposed to simply a broad level of, as 70E Annex E states, principles, controls, and procedures. So even within this diagram, before we ever greeted the 2023 edition of the 70B standard, we already recognized that electrical equipment maintenance programs, previous R-class studies, and previous electrical safety training were all things that, I'll say it this way, in the blue bubble, those were things that companies already did already. But the challenge of then the 70E standard to write an electrical safety plan is to somehow adequately document those in a cohesive way. And this particular approach to a safety plan did that. And here we can clearly see now that as we speak to the 70B references, we're already recognized that electrical equipment maintenance or the maintenance program was literally a subset of the broader audience, at least of electrical system management, if not touching some of these other chapter segments as well. So now, as of today, we're bringing forth the 2023 release of the 70B standard, and in there, the document itself received an entire promotion from the NFPA. So rather than being titled Recommended Practices for Electrical Equipment Maintenance, it's now Standard 4, and that's a really big deal for what we should be considering. And again, let's take a quick shot at what is the significance of that. Well, first of all, then, the elements of the 70B standard are now, frankly, from a compliance standpoint, on par with NFPA 70E requirements for organizations. So in the past, we have seen OSHA take on the guidelines of the 70E standard as being one measuring stick of, in the event of an accident or injury, did the programs as articulated in the 70E standard, were they brawny enough, good enough, and compliant enough that that those met the requirements for safety that OSHA would ask an organization to do. So ultimately, in many cases, when we go back to that original discussion of who decides if we're compliant or not, and the answer is you do, unless for some reason OSHA gets involved, and then they do. so they can look at your programs referencing these various articles of 70E and 70B. And 70B now is going to be that emerging one. There hasn't been, obviously, so little time has gone by for OSHA to say your maintenance requirements were not of what they should be, and part of the responsibility that we're going to lay is your liabilities for this particular accident and incident is in part because of your electrical equipment maintenance requirements and standards. Looks like the industry is going to take us that way, and we'll get that way. And again, those that are in good graces with both the 70E and 70B, and of course Article 70 of how it's built, will have a strong and reliable electrical safety program, a strong, reliable electrical system, and hopefully never see OSHA in because of it. It would be a way to look at that. So again, 70B is what we're going to take a look at here. It's going to give us a basic program structure of defining that safety-related maintenance as we move forward with that. So again, no longer a recommended practice. It's now a standard, and again, we're going to see the results of that within essentially the record keeping and the program management, and the focus on maintaining the electrical system with test inspections and maintenance protocols. And again, in order to document what was done, we do want to look at the various asset management and software and tracking things that folks will need to do in order to frankly document their results there along the way. So Chapter 4 of the 70B standard speaks to a development of an electrical maintenance program and gives us some of the what I'll call table contents of references there. So it's simply put, 70B says we shall now have an electrical maintenance program. And as we take a look at that, our view of the world is the electrical maintenance program is really part of the broader electrical safety program, the way that those chapters were structured earlier in our project approach on that. So again, a documented inventory of the electrical components of your specific assets and assess condition of maintenance and correct deficiencies is just three of the getting started basics of that electrical maintenance program. So again, if we develop a program of periodic test and inspections, that will be part of what we're looking at for the 70B standards on that as we look at that. Again, when you're doing periodic tests and inspections of the electrical system, the first order of business is you would need to inventory the electrical devices. We've always taken the approach, and it's a really good, solid suggestion, that the development of all your documentation needed to put those new components of the electrical system into your arc flash program and have an ongoing support of your arc flash study is just woven into that whole process to do them with a mindset that those are activities of the same result of inventory, test, inspections, and data gathering for arc flash. You're literally in on the equipment and can do that all as one protocol. So going back to our NFPA circle of safety here as we see it, we've got, of course, the National Electric Code to build it. We see the electrical safety plan out of 70E, and now the electrical maintenance program out of 70B as we take a look at that. Well, I'm going to do a bit of an overview of the 70B standard as kind of an introduction here. We're only going to go through chapters 1 through 9 in the overview. There are 36 chapters in total that are active in the 70B standard, but really from chapter 10 and beyond, it's really talking about device-specific maintenance and tasking and things like that. So we can really get a good feel for what's in 70B that is now, again, standards that we need to wrestle with as we simply look at chapters 1 through 9. Interesting, in the actual publication of the book itself, you can probably sit down and read chapters 1 through 9 within, I'm going to say, with a good study of really less than a 2-hour effort. So it does make sense to kind of dig in there and get some familiarity with it. So chapter 1 of the 70B standard, of course, defines its purpose, which really is to safeguard persons and properties from the risk of electrical component failures. Obviously, if we can prevent components from failing and have the type of catastrophic failures that electrical equipment can have, we're also safeguarding our staff and our persons. So we can see that, within that same arena, all of those elements can come together. And then as we look at chapter 2, one of the elements of chapter 2 is a references, and the 70B goes right back and references elements within the National Electric Code of being built correctly, and then elements, of course, of the 2024 edition of the 70E standard from a workplace safety. And as we continue our discussion here, we're going to see a lot of crossover references, and for the sake of those discussions, I put a lot of those notations right into our discussions today. So within the 2018 edition of 70E was the first time that maintenance/condition was defined as a term. And again, that's now brought through as actually a new term in the 70B table of contents of definitions as well. And again, it's the state of electrical equipment considering the manufacturer's instructions, manufacturer's recommendations on maintenance, or in the absence of that information on equipment that's been out there for many, many years, applicable industry codes, industry standards, and recommended practices and tests, etc. So 70B continues with the definition, and if we're familiar with 70E, of course, the qualified individual is a well-defined definition that's been developed over many of the revision cycles, but is also now listed as being in the 70B standard to basically say that work being done in the area of test and inspections needs to be completed by qualified individuals on that. Moving on to chapter 4 is the core of the general requirements that the owner shall again have the requirement to implement and document an electrical maintenance program. And so chapter 4, article 2.1 references that. And again, it then references that the maintenance program can include manufacturer's instructions or the industry consensus standards is where it's going to get most of its content and development on that. So some specific references of the general requirements within an electrical maintenance program is inspections. So here we have the language included in the 70B standard. The 70E standard under Article 110.3B is really a reference to actually only new equipment, whereas in the 70B standard, it's basically the inventory of equipment within the facility itself, as we take a look at that. Condition of maintenance, of course, is the elements of maintaining the electrical system. The electrical reference of Article 110.3 and 70E says you shall have elements of condition of maintenance within your electrical safety plan. And then we have the specific elements here as we keep going within understanding what are those content and our Chapter 4 requirements of 70B that fleshes out that plan a little bit more along the way. So again, a written electrical safety plan is actually referenced within 70B. Qualified individuals are identified, equipment is surveyed, and the documented maintenance procedures by equipment type. All those are, again, things that should be in the electrical maintenance plan as we have it. 70B, the electrical maintenance plan itself then, calls for a periodic inspection, service, and testing of components. If you're going to test and inspect and service, you should have the maintenance records, maintenance records policy, and again, the various aspects of corrective action data when things are inspected and anomalies are encountered, and again, a review process for failures and process improvement on that. So the crossover between we see of 70B and 70E is pretty extensive. Both of those plans between an electrical maintenance plan, electrical safety plan will cross over into both having required principles of the plan itself and again, controls of the plan as referenced within each one of those. The 70B, of course, also now references an element called incident investigations. Again, we see the cross-reference on 70E as well. But 70B does a little bit more detailed job here of talking about specific safety, electrical safety incidents, equipment malfunction. It gives us more of a list in 70B than the more general term within the 70E standard of, again, just incident investigations. Both of the programs, again, share an auditing requirement along the way that the programs or the principles of the written plan shall be audited over time. And then there's a specific reference to training. The 70B standard simply says we need to train our individuals on proper maintenance techniques. And then 70E under Article 110.4 does a whole lot more of establishing the safety protocols and safety-related fundamentals for qualified individuals doing work within that energized mode along the way. So as again, we can see how these are all kind of interrelated here along the way. Chapter 5 of the 70B standard is like 2 paragraphs long. It doesn't even really even extend out to more than a quarter of a page, and it's 1 column within the page. And it simply says that electrical maintenance work needs to be performed by qualified individuals. And then we can go back to the 70E standards to really develop the entire understanding of who is a qualified individual, how do we develop them to be qualified for the task that they're asked to do, that type of a reference on that. And then there's one more reference in the 70B that says that, the qualified individual may have its other guideline requirements from state, federal, or local standards of specifically the references to identify hazards and reduce the associated risk and encounters that our personnel would face as they do the work that they do. Chapter 6 and 70B is a pretty new one, and this has some really, I would say, much more powerful results on that, because it does cross-reference the 70B type requirements from time to time, but it even goes further as I see it. So when you look at 70E and ultimately being able to do an ARC flash study and post up labels, conceptually you can do that with the various data collection, do what it takes to do label calculation, print labels, and call it done. So when we look at that, the requirements that could be met by that narrow of a project is ultimately developing the single line diagram and developing the incident energy analysis or program results. The middle two of a short circuit study or a coordination study are now requirements in 70B. There's no requirement in 70E that discusses that a coordination study be done. And the audit that's needed to do a short circuit study or short circuit audit is now clearly defined with 70B, but a very cursory reference under Article 210.6 that says that devices shall be properly rated within 70E. It said that it'll be properly rated, but doesn't specifically ask for a short circuit current study doing that type of work on that. So we can see again how these weave together. Now in practice, frankly, using our EasyPower software, the results of incident energy, short circuit study, and coordination are part of the baseline, I'm going to call it data created by the EasyPower engineering software, and the scope of a reasonably solid and broad scope arc flash risk assessment study would already encompass at least those 3 specific study metrics as suggested now within the 70E standard as well. So long story short, we've been doing those types of studies within our project scopes of arc flash studies for quite some time now as we have them. So again, the EasyPower models provide us the ability to share data across all 3 of those within the same build of doing incident energy and delivering arc flash label data and results. So one of the key metrics, though, of all of these studies focuses on the concept of data collection. So as you begin the process of inventorying your electrical system, how deep does your inventory go, and do you develop, I'm going to call it, the additional specifications needed that are used by the engineering software to go and support those other studies? So as you inventory your electrical systems, for example, will you be recording the AIC ratings on breakers that are literally listed right on the devices themselves? Type results. Are you recording levels of wire sizes and distances as you inspect those individual electrical components? Because those are some of those elements needed in order to ultimately develop the aspects of the incident energy model. So in result, quality of data collection means the quality of how those studies are going to turn out over time. And again, the surveys that use IR testing with it, frankly, allow you to do better data collection, because one of the requirements of doing IR testing that we'll see down the road here in just a bit is that panel covers should be completely removed, which gives you better line of sight to many of the other, I call it, specifications and attributes of the electrical system, that technicians that can be data gathered. And again, in that mode, because you are dealing with energized components, in order to do the infrared testing, your technicians need to be highly qualified in terms of that qualified individual status. So here's a bit of a summary of the electrical maintenance program and the various topics that we've covered today on that, and both their summary of where you can see a particular reference in 70E 2024, as well as now in 70B the 2023 edition, where we literally see these various overlaps and cross references of all of these elements being part of safety-related maintenance as we pull them together. Chapter 2 of the 70E standard is titled Safety-Related Maintenance, and yet it has a fairly narrow scope. That first of all, the narrow scope of the 70E standard basically says we're going to look at only maintenance requirements directly associated with employee safety, not necessarily equipment safety. And ultimately, again, as we look at safety-related maintenance requirements, again, it was in the mission statement of 70E. But in general, Chapter 2 really is a really highlighted version of that from the 70E documentation. We're going to find much more detail and build out as we understand that in the 70B standard. So 70E does give us this definition of again, maintenance as defined as preserving and restoring, but also interesting, Article 100 or 200.1 of the Chapter 2 of 70E basically says it's up to the employee or that facility management staff to determine what tests and what frequency is going to be part of building out the, I'm going to call it the metrics of the now overall electrical maintenance program as well with that. Moving on to Chapter 7, we're almost done. We're getting close to Chapter 9 here. So Chapter 7 is titled Fundamental Tests, and while I won't go through all of them, infrared thermography is one that deserves a specific reference. I have encountered many discussions with facility managers where the metrics as we now see in this particular article reference of infrared thermography and a fundamental test have not been followed by those who practice infrared in the field. So today, a appropriate and by standard infrared survey would require that the various covers and protected devices be removed to provide a clear line of sight to the various terminations and connections within the electrical components, and thereby being your test subjects are then visible. Without the removal of those panel covers, many of the terminations and such of the panels would be inaccessible to the true infrared assessment on that, and therefore what kind of test are you doing if you're trying to use an infrared camera and trying to go through a protective cover that it doesn't work type result on that. The 7.4 here for infrared thermography also looks to define a means to both perform the infrared thermography under normal loads where possible, but also now to document the load characteristics. So you would essentially be taking energized load readings along with your infrared thermography assessment or test of the day and documenting that as being part of your thermographic test. So you can see that those are significantly, I'm going to say, higher standards than in some cases what we have seen practiced in the marketplace. And of course, all of that requires qualified individuals, and in some cases even training on the ins and outs of the infrared thermography protocols itself. So again, as we look at that, it gets back to who is the qualified individual, and again, are they qualified to perform that level of tests and inspections along the way. Chapter 8 sets us up for understanding the various field testing, test methods, and test forms. Again, we're referencing condition of maintenance results, what are results that should be documented, and then even references that the test equipment being used has its requirements to be properly calibrated and kept current in its performance metrics as well. Chapter 9 is a fundamental piece of the 70B standard because it will really give facility managers and maintenance managers the means to develop the program of their electrical maintenance program. The title is Maintenance Intervals Along the Way. It goes through what I'll call a triage assessment of the condition of the devices. And one of the derivatives that comes out of that then is recommendations for the frequency of tests. And at the end of the day, a maintenance manager needs to basically have a well-defined understanding of, here's my inventory of all of my electrical components by device type. This is the type of scope of work and assessment we're going to do in terms of tests and inspections, and what is our frequency of inspections. And many times in this particular area, the day-to-day operations of the staffs are so challenged that there really isn't an opportunity, or at times the methodologies, to do a very structured approach to go through the inventory of all electrical components and meet these type of test and inspections, and again document the frequency of those type results. So in a quick review here, the maintenance intervals of Chapter 9 are defined with conditions 1, 2, and 3. And so condition 1 will generally say you can do intervals if your equipment meets this condition 1 status of, I'll just say, not to exceed or up to 5 years, that generally 60-month protocol. So equipment will be in like new condition. The enclosures themselves are clean and free, and are in probably an environment that they stay relatively clean as well. That there's no open issues from any type of continuous monitoring, any other recommendations from past predictive maintenance inspections, and are you current with those inspections from those devices to begin with. So all of that would be a criteria that would take a group of equipment and move it into this, I'm going to say, a 5-year cycle of test inspections and reviews. A shorter cycle comes to us with chapter or condition 2, and again, the results there is, did we have maintenance results that didn't quite stack up to what was done in the past? Again, our cleanliness issues and what kind of environment we have related to cleanliness. Do we have open issues from any type of monitoring in place? And do we have active recommendations from past previous predictive maintenance techniques and such? And again, that will ease it up to move it into a more tighter approach of test and inspections. Condition 3 is the last, which is again a general interval of about a year or less. Equipment that's been missed in cycles, has open issues, or just simply has urgent actions from predictive maintenance of that. A urgent action for predictive maintenance might be a critical heat signature from the infrared, something that would typically want to be required to have some level of immediate response of resolving or even replacing components that would have that type of a problem. So we can see that Chapter 9 then gives us this structure of assessing all of our equipment and then the intervals thereof from there. And then the last reference back to Chapter 4 here references that the electrical maintenance program shall be designed to function in conjunction with the electrical safety plan. So again, we see that tie back between I'm going to say a broader electrical safety plan, a more specific electrical maintenance plan. And then even in the structure of that electrical safety plan, I'll comment that there's almost another sub-plan of your lockout tagout protocols by devices. And that may not be what I call a sub-plan because of those other energy sources that have to be included in lockout tagout other than electrical that make, again, a lockout tagout program somewhat more detailed and somewhat unique compared to broader elements of the broader electrical safety plan requirements along the way. So again, as we see this all coming together, we can take a look at this version of a broad electrical safety plan, look at the safety related maintenance and realize that, here are those activities in the blue bubble that ultimately give us the documentation needed to flesh out the various requirements within a broader electrical safety plan of the facility at hand for that. Again, we're going to close our presentation today with this particular discussion. It's a reminder that NFPA doesn't go and basically approve, deny, or certify any of my discussions of today's presentation on that. So today's presentation is our assessment of implementation and assessment of what we all call compliance challenges and compliance issues within the standard on that. And with that, I'll say we wrapped up the presentation side of this, and I'll turn this back to Jim and see what he has in terms of questions and answers for us.
Thank you, Chuck. Good job. Yeah, we do have a couple of questions that came in during your presentation.
Let's have at them.
Well, the first one is the infrared thermography a requirement? Is it mandatory?
Under chapter 7 of the 7dB standard, the title of that chapter is now referred to as fundamental tests. So within that specific section, or their infrared is considered a required fundamental test. And there's additional ones of basically insulation resistance testing, torque verification, and contact resistance as well, being elements of test protocols that ultimately can be part of your test and inspection programs. So when you look at that scheme of, we're going to look at our inventory, we should be doing this test and inspections, what ultimately should be in there. The way we look at that is there's basically the energized components, which is the infrared testing, visual inspection, and in higher level equipment, you can also use ultrasonic screening to determine whether you've got some insulation issues or some other types of problems that the ultrasonic tool can pick up as a screening profile. And then there's the de-energized protocols of testing, which ultimately would be torque verification, insulation resistance is a de-energized test, and the protocols there. With regard to testing, again, infrared specifically is recognized as one of the fundamental tests as it happens. I think we could leave that question there, but the next piece of that is there's other tests out there that can provide, I'm going to say, advanced levels of testing. One of them, as a really great example, is on most electronic breakers today. The electronic trip setting modules themselves have testing ports that you can bring in a protocol called secondary injection testing. Transformers, you could hook up meters and do transformer turns ratio testing. All of these protocols basically do one thing, and they say, let's assess the condition of these components compared to their manufacturer specifications, and are they running essentially close to the manufacturer specifications as first presented for those particular devices. So you can go pretty deep into some of these testing aspects, but again, the basics here is, yes, I would say infrared is one of those fundamental, it's described as a fundamental test.
All right. Two other questions kind of dovetail. Why has the promotion of NFPA 70B to a standard been made into such an event when the NETA testing standards have been a consensus standard by ANSI for a long time? It seems they're in competition.
Boy, that is a good question. I'm not sure I'm capable to answer a deeper question on that, but again, the standards other than 7dB are again other industry consensus standards. They don't necessarily are, I'm going to say, derived from NFPA. And again, NFPA ultimately, as they make their publications, I'm going to call it as one opinion of those standards in the marketplace. And certainly these other NETA standards and such that have been around a while develop their own protocols of, again, what are good industry practices related to safety-related maintenance, tests, and inspections. So I guess I'd have to agree that what's the why behind it, other than, there's the consistency of what comes out of NFPA documentation. And again, today I think we showed the evolving and the weaving of safety in the workplace for people and now safety in the workplace for equipment as where NFPA is taking their, I'm going to call it, safety practices along the way. And as I see 70E and 7dB working together, we get that much more that we keep people safe with good electrical safety practices. And to be honest, I think the only thing 7dB did not maybe do as well as it could have is, does it somehow reference and take a look at, again, those other, I'm going to call them competing organizations that also put forth standards of performance.
Interesting. Well, thank you very much for an excellent presentation.
My pleasure, Jim. It's our second go around on topics, and we look forward to working with EasyPower at some point in time in the future again.
We'd love to have you back. Thanks to everyone for attending today. We'll have the video recording up on the website probably early next week. Thanks again. We'll see you all down the road.